Hi, this is Mrs McTaggart and this is my second probability video. This time we're going to look at calculating the probability from a table. So these used to be really common questions in the old days of general and credit maths. But they're making a wee comeback with National 5 applications. So what we've got here is a little table that shows the results of a survey of an S2 class. We were asking how many siblings they had, so that's how many brothers or sisters. And you can see it's been divided up into male and females and no siblings, one sibling. And then this little symbol here that means more than one sibling. So greater than one is what that says. So let's have a little look. First question said what was the number of pupils in the class. So we need to add up all these numbers. So I have got 7 add 7 is 14, 15, 20, 28, 30. So I've got 30 pupils in the class. That was quite easy. I must have chosen numbers that added up easily. So there's 30 pupils in the class. So that means all my probabilities will start with being out of 30. So I've led you into the question. So question B says, what is the probability of a male who is an only child? So you go to the male column, you go to the 0 sibling column and see where it overlaps. So there are 5 males with no siblings. So that means you've got a 5 out of 30 chance of being an only child and a male. Now with all things with fractions, this must simplify. Using the 5 times table, that goes down to 1 out of 6. Then for part C, it says, what is the probability of having more than one sibling? So what you do here is you go to the column that says more than one sibling. So there was 2 boys and there was 2 girls that had more than one sibling. So that is a total of 7 people out of 30. No, it's a total of 9 people out of 30. And then 9 out of 30 simplifies using the 3 times table and goes down to 3 out of 10. So you have a 3 in 10 chance of having more than one sibling. Is that all right? Let's have a look at another one. I've only got a couple. So here's another similar table. This time we're looking at some S1 test results. And you're being split up into males or females, passed or failed. So luckily there's a lot more passes here than fails, so not too bad a class. So first question is how many pupils sat the test? So I have got 9 add 11 add 3 add 1, that's 24 pupils. So 24 pupils in the class. First question, what is the probability of picking a test at random? And it's a boys script. So there is 9 boys who passed and 9 boys that failed. That is 12 boys altogether. So probability of being a boy in this class is 12 out of 24, and that simplifies down using the 12 times table. That's half. So half the class were boys. Then we have this one, probability of any pupil that failed. So 3 boys failed, 1 girl failed. So that's 4 people. So 4 fails out of a possible 24 pupils. And that simplifies down using the 4 times table to 1 out of 6. And then the last question, probability of a girl that failed, not many of them, there was only 1. So 1 girl out of 24 in the class failed the test. So let's see what else we've got. Not all my examples come from tables, they actually come from different statistical diagrams. So this is obviously a pie chart. And there was another part to this question, but it wasn't really relevant to probability, so I've only included the part B. So 72 employees were asked how many hours overtime they did 1 month. And you can see that some said between 0 and 4, 5 and 9 and so on. So the question says, what is the probability that someone worked 9 hours or less? So 9 hours and less are these people here and these people here. So we know like half of them did 0 to 4, but what's that missing little bit here? So you need to know about angles in a pie chart here. So at the moment, I know I've got 180. I've got that right angle for 10 to 14, which is 90, and then I've got that other 30 degrees. If I add all these up, I have 9 add 3 is 12, add 8 is 20, and then 2 add 1 is 3. So the pie chart counts for 300 degrees. So this little missing bit in here is 60 degrees. So the angle that represents the people who worked 9 hours or less is 240 degrees. Now that's 240 degrees out of 360. If I simplify that down, that's 2/3. Don't know how good you are at your simplification. Take off the zeros, I've got 24 over 36. Divide by 12, I've got 2/3. Now the 72 is completely irrelevant. It's not asking how many people. That was the part A, which I'd hidden for this bit here. Basically, 2/3 of that pie chart worked 9 hours or less. These people here. So the probability that the person chosen at random worked that amount of hours was 2/3. Let's look at another diagram. Do you remember these? Stem and leaf diagrams. So this stem and leaf diagram shows the number of points given to football teams in the Premier League in a season. What is the probability that a team chose at random scored less than 44 points? So you could spend all day counting up how many teams you've got, or you could look at your key. There were 20 teams listed in this table. Probability that someone scored less than 44 are these guys here. I'm going to circle 1, 2, 3, 4, 5. Now, whenever this crops up in a test, people say, do you include the 44? No, you don't. Read the question. It says less than. So you're only looking at the numbers less than 44. So there was 5 there out of a possible 20. And 5 out of 20 simplifies down using the 5 times table to 1 out of 4. So 1 in 4 chance. If you were to include the 44, it would say what is the probability that a team chosen at random scored 44 or less. So watch the language in it. So that's me kind of showing you a bit of probability from loads of different statistical diagrams. I hope that's helped. Thanks for watching.